web security, HTML, and CSS syntax, and then went into using Node.js and JavaScript to build a basic TCP client and server. So the slides and the code, the links are here on this slide. I also posted them in the chat at the beginning of this meeting. If you're interested in following along, it may be really great to look at the code because the slides, I've tried to copy paste from the slides and gotten a lot of errors from that. So your other option would either be manually typing it entirely, or you can just use the code that's provided to copy paste. So that may make things a bit easier. So again, this is recap from last week, and you can find this code in the GitHub repository, but here's our basic server in Node.js. So we are basically just calling a built-in JavaScript module called net to create a server. All we do is write hello to the socket, and then we listen on port 8000. So you can access this at port 8000 on your, well, just access it by using localhost. Then we have a client that we built, and what the client does is we can pass in a port number that we want. We pass in localhost as the IP address that we're trying to connect to, and then we connect to it, and then we try to write something to the server. We can also print out the data that we receive from the client, and then close the connection after we get that. So that's our client and server from last time. So here is a reminder of how to run this. So just as with last time, you do need to download Node.js, I believe version 12. I think the right version is listed on GitHub. And so just open up two terminals, use Node to run your server, and then in another terminal, you can run the client. So if you did not make it to part 1, that is basically what all of part 1 led up to. So you can find that code in GitHub. So in terms of goals for today's workshop, I realized last time that we built a server, but then didn't necessarily explain what things like TCP actually are. So we're just going to do a very, very light description of that, as well as just basic networking, which ties into that. And then we're going to continue building a client server. So we're going to go a bit more into just general JavaScript syntax by returning the current time whenever a client makes a request to our TCP server. Then we're going to make a server that uses the HTTP protocol instead of TCP, first returning JSON data to the client, and then returning an HTML web page and handling a post request for a form on that web page. So why do we really care about networking? As mentioned at the beginning of this, a lot of people consider web security as like SQL injection, cross-site scripting, and those things are really important. But at the same time, even if you just start out in a huge React or Angular web app, everything still requires networking under the hood that you have. And it can be a major source of security vulnerabilities. Something that is really common is people having things such as their database just being publicly available for anybody to access because they did not properly configure the networking aspect of it. And so maybe you don't necessarily want anyone to be able to connect to your database when all they need to do is find the right IP and port number. I think that it's, as mentioned last time, it's useful to know about for if you're interested in going into network engineering positions at some companies that were previously mentioned, like maybe Cisco or other like phone companies, but also for general software engineering. Once again, going back to our really abstracted away huge web app built on a really heavy framework, you're likely going to need to use an API to get data from somewhere and display it. So you may have issues with that if it's really complicated API or maybe complicated protocol. And so something that you likely will have to do if you do any sort of software engineering in this regard will be capturing network traffic of some kind and being able to confirm that everything is working as expected. We aren't going into capturing network traffic in this workshop, but I think it is something that I would like to do at some point this semester. So expect that at some point. So this is a very, very, very broad overview of just the question of how does the internet work? And basically it is a bunch of stuff shoved together, a big network made of smaller networks and things that basically route everything to the right place. Generally, I previously mentioned the network protocol stack, I believe, or I guess just the network stack. So this is something that I personally have been asked about before in interviews, and depending on what positions you apply for, you also may be asked about different parts of the network stack. Basically, the answer here is just memorize it. So there are different layers to the network of differing level of abstraction. Of course, like it starts out on like the physical network, but then basically it goes higher and higher until we get to like the application layer, where it is just a certain application, like as mentioned, or as listed here, like the HTTP protocol, which is built on top of using TCP and then is used for web traffic. So yeah, we have a stack, it does stuff. So what were previously mentioned and what we did previously was building a server using TCP. So two basic protocols that are used very widely are TCP and UDP for the Internet Protocol Suite. So TCP, basically, it requires this thing called a handshake. So in the last workshop, there was a random picture of people shaking hands, and it was never really explained, and that's why it was there. So basically, a request is sent, and then the other machine that is getting the request needs to acknowledge that. So basically, they just need to confirm with each other that a connection is being established, and then data gets sent. TCP prioritizes accuracy, unlike UDP, which is something else that you can use. But basically, instead of making sure that everything is in order, instead of trying to focus on accuracy of data or if packets are actually sent, it may just kind of throw a bunch of packets at somebody and not really care that much. So they have their uses. Other protocols, as mentioned, like HTTP, are built on top of TCP. And in general, if you're wondering like what exactly is a protocol, it just depends on the protocol, but it is just some standardized form of communication where they know that there is a fixed format of different data that's sent. If you just Google like TCP, then you can see a specific breakdown of what is actually being sent in a TCP request. So as mentioned, different protocols are built on top of things like TCP or UDP. So if you want, you can define your own protocol on top of TCP for your own connections. So shown as an example of what your really basic protocol could be, where the first 32 bits of your message is just going to be the number of bytes in the remaining message, and then the rest of it is the actual message content, so that whoever is receiving the request actually knows how long it is supposed to be, and then can only loop through for that long to make sure that they actually got the request. Something that is shown here. And let's see, going to try to open the link here. So this is just a fun blog post that I read like a few days ago. So if we paste here, oh, sorry. Okay. If we paste here, then this is, okay, trying to full screen and then the Zoom UI got in the way. Okay, so basically this is a blog post of somebody hacking a smart coffee machine. While I don't really think a coffee machine is going to be a particularly meaningful attack vector, because if it's hacked, you can just throw away your coffee machine. There's not really anything sensitive going on there. It's a fun read. And so one of the big things that happens is that all they do is capture some unencrypted network traffic. And you can just see what exactly is in unencrypted traffic. So for the security researchers, I guess, who tried to hack this coffee machine, they just, again, looked at the network traffic and were able to figure out what the protocol looked like. So here it has like a specific command, some data, and then can return for this, which is a command to send to a coffee maker. and then the coffee maker sends a response back. So the way the coffee maker works is that it has an app that you can use to control it. So it does this by using this basic protocol. Your phone sends a request to the machine, which is on certain TCP port, which this claims is 2081. So much like we're just calling like localhost 8000 to go to our server, basically they're just doing something that is the same for this coffee maker. And they were able to figure out the command just by looking, again, at unencrypted network traffic pretty easily, after which, once you know that protocol, or once they knew the protocol, they were just able to make requests themselves to the coffee maker. So I guess they could do really interesting hacks, like, I guess, make boiling water come out of the coffee machine. Again, I don't really think it's a particularly dangerous attack vector, but I thought it was fun. And if we were in person, I think it would be fun for us to do something similar in person. So that is a reason why maybe it would be interesting to look at TCP protocol or TCP network traffic, and you can just look at your IoT devices like that and figure out what they're doing if they don't particularly have good security. So now that we have our brief intro, I guess before we get into the code, does anybody have any questions or just comments on this? As mentioned, it was pretty hand-wavy, and if you are really interested in doing further networking stuff, we can definitely hold future workshops and do things like, as mentioned, look at networking traffic. Or you can also take classes like CS438, which is Intro to Networks. So any questions? And if not, then I'll just get into the code that we have here. Okay, I'll take that as a no then. So we can move forward then. So here we have our previous server, and the question here is, how can we write the current time to the client that sends us a request? Why are we doing this? Really just because I thought it would be a nice problem to look at for just looking into JavaScript syntax a little bit more outside of just calling this net.createServer function. So what you can do in JavaScript to get the new date, you can use their built-in date functionality, which is really handy. And as shown here, you can just call new date and you get the current time. So we're going to try to display the time in a given format. So here, this is just the format that we're given. Since it's the format we're given, that's just what we're going with. So we have the year, month, day, and then the current hour and minute, and then just a new line at the end so that it looks nicer on the terminal. So here are a few other functions that could be really useful for this, where you can call different built-in functions like get the entire year, get the month, get date, get hours, and get minutes. Some of these functions are weird, so as always, reading the documentation is great here, because you may notice, for example, that get month starts at 0 for some reason, and that's great. So something that we need to do is concatenate strings in JavaScript. So you may have just done this in Python, where you can just write a string and then add another string to it. So shown here is an example where we have a string, and then we're doing our string part where it's 5 plus 10 is, and then we're just doing 5 plus 10, which, as you can see, are actually integers. What's nice about this, or what I found nice about this, is like, whereas Python, I want to do this really easily, but then I have to cast the integer to a string, JavaScript seems to do this pretty nicely already, though at times it is a bit of a downside, but here I think it's great. So specifically, this is the code that we have here. So our current timestamp is going to be, we're going to call get the year to see what our current year is. We're going to add a dash. We're going to add get month, another dash, get date, a space, and so on. So format the string as expected. And this works for the most part. But if we do move on, then I believe, okay, so before we get to that, the potential issues with this, I guess we can actually just shove it into, so we have this code, and then we're just shoving it into the place where we are handling a new connection. So we want to get a new date every time someone connects, rather than maybe outside of that, because maybe we maybe we're running the server for a long time and a lot of clients are connecting. So yeah, we're getting our new date, or making some function calls. Pretty straightforward here. So then, as mentioned, we have a problem. So if you ran the code just like this, then you may notice that there was just a very minor issue here where we specifically wanted it to have the same number of characters regardless of what the actual value is. But let's say that our number is less than 10, it's not necessarily going to follow our desired format with 2 digits. We also have another problem where getMonth starts at 0, so it's not really returning what we're expected. As you'll see though, that will be a pretty quick fix. So for that, all we're doing is adding one. Really complicated stuff here, as you can see. So then for the rest of it, we just need to check for the number of digits on each of our dates. So here we are just going to use our nice operator that is, I don't know, you can also use an if statement to achieve the same functionality. I just think this looks pretty cool. So you have your condition, you have a question mark, then if that is satisfied, then you have a certain thing that you can do. Else, basically your else is what comes after the colon here, and maybe you don't need to pad it. So we're just checking if it's less than 10, we're padding it with a 0, otherwise we don't need to pad it with a 0 because it's already 2 digits. So as previously mentioned, this is more of just a general programming thing. This operator is available in a lot of languages outside of JavaScript, but it is logically equivalent to just using an if statement. Except it looks like my if statement does not have an else. So if you did use an if statement, you would need to actually add that else value, I suppose. Or, well, okay, never mind. I forgot what my own code does, but it looks like I am only adding a 0 if it's less than 10, so we should be fine. So moving on, as you can see, this looks really great where we are just copy pasting 3 times to maybe consider padding with a 0 or not. Of course, we could do a little bit better than that in terms of our code style. So our problem right now is we are repeating the same code, which is not necessarily what we wanted. And so our answer is going to be refactoring it just because we want a little bit of good style here. So here, you can actually see the syntax for declaring a function in JavaScript, which may be helpful for most things that you do in JavaScript. So we're just declaring a function, and then we have the name of the function, and then you don't actually need to specify the type of the data in JavaScript. So you just have your input, and then here we are just returning, we are again using the same if-else statement that we used previously and just putting that into a function. So now what we can do is just call our function to make that look a little bit more readable. So moving on, we want to be able to take in any port instead of just port 8000. So as you can see, we do have 8000 hard-coded, but we want to change that so that whenever a user wants to change the port that they're running on, they can do so very easily. So this is a little bit of a side note, but generally, command line arguments can be passed into any program. So for example, like in Java, not JavaScript, this is something that I guess I was confused on for a while because nobody ever explained it in intro Java, but I was always confused at why the IDE was like command line arguments, put these here. And so really, if you don't use an IDE for your Java, you can just compile Java on the command line and pass in those arguments, which end up being an array. Depending on the language, you may need to parse it a little bit more. So typically, these arguments are going to be called argv in the code, but again, it does depend on the language. So in Node.js, actually, I'm not sure, this may be, is this JavaScript in general? No, I think this is just specific to Node.js. So processes are basically how programs are run when compiled, but basically that is something that's going to be covered pretty heavily in CS241. So you don't really need to think about it here. So you're just doing process.argv to access your command line arguments. So here it's an array, and so the first command line argument was node. The second argument was the name of the thing, the file that we are passing into node to compile with, and then the port number is going to be actually at index 2, which you might not necessarily have expected because you might not necessarily have expected Node and timeserver.js to both be passed into code, but it does get passed in. So we can, instead of hard coding 8,000, we can just replace that with argv at index 2, because we know that, or if we tell the user that they just need to pass in the port, then it's always going to be at index 2 of argv. So here is our final solution for that. And this is the final version of the code, which you can find on GitHub. And I can try to run it, and hopefully, I mean, of course I tested this before the workshop, but things always go wrong when you actually try it. So the way you can test it is just using the client that we previously built. Ooh, okay, sorry, the font is kind of small here. Let me try quickly to zoom in. Okay, is this more legible, hopefully? Okay, so what we are going to do here then is we can still use our original client here, and then we have our server that was just mentioned. So in one terminal, we are going to call, actually okay, I needed to remember the directory. So we are just going to do web security R2 time server, and then we're running it on port 8000. So we have our server running. We're good. So now we're going to go into the next one, where now we are going to call our client. So the client is in part 1, so that's what we're accessing, and then we're going to try to request at port 8000. So we connected at port 8000, and we got back a date, which is in the format that we expected. I guess this is the current time. Yeah, okay, looks about right. So it works. So, oh, okay. Thought that would start at the current slide, but I guess not. Okay, so that concludes for now, I believe, our TCP requests going back and forth. So now we want to answer the question of, okay, so I can get data back in string format on the command line, but how do I actually use like my web browser and see a web page from a web server? So we need to move on to using HTTP requests instead of using TCP. So first we're just going to create a HTTP server that returns JSON. And then after that, we will do a web page. A React app is mentioned, but that is not in the scope of this workshop. I think that if we do one more web security thing, then it will be the traditional web security you may have been expecting, where we actually are going to patch issues like, as mentioned, SQL injection and cross-site scripting. But for now, this is just focusing on the fundamental networking aspect, because I think it's interesting. And as mentioned, because you're very likely going to need to capture network traffic, either if you want to hack your coffee machine, or if you're just doing web development and you're trying to debug an API call, I think it's really useful to have some general network understanding. So before we move on to this, I guess, does anyone have any questions about the server that we just built? If everyone is good, then we can move on. Okay. So what is HTTP? As mentioned, basically it is used for web stuff, especially things like HTML. So copy pasted here is a definition, but also you can Google what is HTTP and get a lot of explanations. So it is built on top of TCP IP and all of the other networking layers that go below that. So your first question may be like, how do we handle it differently from TCP? How do we specify that we're sending an HTTP request instead of just TCP? And the answer here is that we can use the built-in HTTP module for JavaScript instead of net. So it's really great that we have that built in. So shown here is the code for building an HTTP server in Node.js instead of using TCP. So we just require HTTP. We are creating our server. You may see that the function input has a request and then RAS result. I don't remember what both of them do, but anyway, main point being, okay, I believe that the new one is actually a request, not a result. So that is unlike our TCP server, where we don't necessarily have a request like that. So generally, I think later this will be explained, but basically there are two big requests for HTTP, which are called GET and POST. So we're going to start with handling GET requests and sending out JSON data. Then after that, we'll move on to a web page and handling POST requests. So for now, our goal is building a server that takes a GET request input, and we're going to handle two different URLs to show how you can parse different URLs when you have a web server. So for one of them, it is going to be API/parse time, and we are going to expect a timestamp as input and return some JSON as output. Unix time will expect the same parameter, but will return it in a slightly different format with Unix time. So yeah, listed here is the idea credit. This is some guy who taught some Stanford web security course where this, again, was another thing as a homework assignment for Stanford students. So I thought it was fun, and I thought that, I guess that's why we're doing it. So as mentioned, HTTP requests are usually, the difference will be GET and POST. So to make a GET request, all you have to do is pass it into the URL. So as shown, if we're trying to pass in our ISO date, all we have to do is go to the URL. So as you'll see, we'll go to localhost port 8000/API/Unix time, and then we type in the ISO part into our browser directly. But post request data is not visible in a URL. So we go to the URL, and then separately in the post request include the data that we want to upload. Generally, for things like login, you are definitely going to want to use post requests because maybe you don't necessarily want usernames or a password in your browser. So basically what happens if you don't use post for forms, you could have a URL like home/user-ID equals whatever. So you could access anyone else's homepage by just changing the user ID. Which maybe you don't necessarily want your users to be able to do if their sites are supposed to be private. So GET requests can also be cached in your browser, and POST would not be, so maybe you don't necessarily want that to be cached, but far more important than that. Like, that's a really minor thing. The most important thing is just not having the things like user ID and password in your URL. So yeah, it could just be stored or recommended. So yeah, what we are then going to do, as mentioned, is build our server that takes in a GET request input at two different URLs. So the question may be, how do we know which URL is actually being requested by whoever sends us a request? So there is an answer here. So we can actually print out, I believe, the entire request if you're curious about what the HTTP format is. So you can just do console.log rec, and then you will have, when you run the server, you can print all of that out to see everything if you're more curious about the details of the request that's being sent. So we also need the URL module in addition to HTTP. I don't think it's absolutely necessary, but it makes parsing the URL much easier. So that's why we're going with it. So as you can see, the two lines here are parsing the URL that is given to us, and then also parsing the query that the user made. So maybe that's like the passing in the ISO time to be whatever timestamp that they want to be reformatted. So sorry, I'm just unsure of if there's any difference between the code on these two slides, but it looks like they're the same. So I'm not really sure why I did this, but maybe I'll figure it out. So we're wondering how to parse the URL, see what we have. So then what we need to do then is just do a nice if statement to see what so after we parse the URL, again, if you're curious about the specific format that's given, I suggest like downloading the code on GitHub and just add like console.log URL parts and just see what the output is. So here we are checking for if the path name matches API/parse time. And then if it is that, then we'll handle that. Otherwise, we can also check for API/Unix time and handle that. And then otherwise, just handle any other URL however we want. I think it's just going to be a blank else statement for the scope of this server. So another side note about HTTP, maybe sometimes you try to click on a certain link and then you get something like error 404, and you may have wondered, what does that mean? So there are different codes that designate the status of an HTTP request. Basically, some mean that something worked really well, some mean that something went wrong, and some specific numbers are used to state exactly what went wrong in some cases. So maybe, for example, sometimes like you may get a certain error code that's like, okay, it's a problem on your end, or you may get a different error code that says, okay, it's a problem with the server you're requesting to. There's nothing wrong with you. So the only thing that you need to know for the scope of this is that we are always going to set our status as 200 because everything is just always okay. Whenever we get a request, we're just going to handle it just fine and return our JSON or our web page or whatever, and everything will work. So you can do that by setting, you can do write head to write it's just called the HTTP header, which has different metadata about a request. So we are setting the code to 200, and then you can also specifically set the type of content. So you can do things like text or other stuff like that. But here the content type is JSON. So that's why we're setting the content type to JSON here. So for both the API parse time and Unix time, we are sending back JSON. So that's why we're setting that to type JSON. So then after that, we can actually create our JSON and look a bit more at the date functionality. This looks a little bit messy because I was just trying to get it all onto one slide. But again, if you look at the code on GitHub, you can actually see the JSON being expanded a little bit more to multiple lines. If you're unfamiliar with JSON, basically it's just a format that you can put things in. So you specify the name of something, and then you specify the type if you're designing a schema, or if you're using it in practice. As you can see here, we don't even need to know what schema. We're just hoping that someone else knows what it is. So you have your curly brackets. You could just do something like hour and then put in any number you want, minute, pass in any number, and whoever gets the JSON can just call like my JSON and then add hour and then be able to get the value that is corresponding to the hour. So it's a pretty nice format that a lot of people use. I would say other than JSON, another format commonly used would be XML. So yeah, we have our JSON. And then after we are making our JSON and playing around with just creating a new date and formatting stuff, as always, we are ending our request to make sure that to show whoever is getting the data that there's no more data to be given. And so the JSON, as you can see, it's not necessarily a string when being stored in JavaScript. So our solution to that is call a function called stringify and pass in the JSON. And it just turns our JSON into a string. And then whoever receives it can just, I don't remember the exact name of the command, but they just have to call JSON dot another function, and then their string will be very conveniently parsed into the format that was previously mentioned, where you can just do like JSON at hour and then get the value. So that's generally what we're doing to handle that.
Wait, Danielle.
Yeah.
Before you go on, can you please like just describe the difference between ISO time and Unix time?
Yeah, so ISO time, I believe as mentioned, I don't remember the specific format, but we are just parsing separately into the hour, minute, and second as just like you would expect to read it as like a human. So like hour is like, I don't know, 19, minute and stuff is exactly what you expect. Unix time is a little bit different in that I believe Unix time is actually basically just a really big number, and that's all the information that you have. I believe it's the amount of time that has passed since like some day in 1970, and so it is just all of the seconds that have passed after that. Let's actually see what the outputs are though, and make sure that I got that right, because I may be thinking of a different format, but I think that's the difference. So yeah, as shown here, the other part of the if statement was kind of removed for readability because it was a lot of lines of code and it's hard to shove that all into one side. So now we are doing some more JSON parsing under our Unix time URL, where we are just calling the getTime function. And as mentioned, hopefully I remember what Unix time actually is, and it really is the number of seconds passed since like that one day in 1970. And then we are having a more basic JSON schema where we just have one field, which is Unix time, and then the time. And then we're also doing end there. So how can we test this? Originally, I tested this using curl, and then last night when I was making sure that this works, I realized that it doesn't necessarily work on Windows. I'm not sure what version of curl I have, but the same command that worked on Unix command line did not work at all for me on Windows. So you might not want to use that, but you can also just open your web browser and test this. So let's see. So going back to this terminal, I want to close this because otherwise it will be unhappy that something else is using port 8000. And then we are going to call my HTTP server, and that's running. So HTTP server is where you can find the code that we just walked through, where we have our HTTP server and we're parsing our URL, and then we are just doing all the stuff that's mentioned. Here's the JSON that is just slightly more expanded, where here you can just see we have curly brackets, and then inside all we have to do is just say hour is equal to this, minute is equal to this. It's really nice. So, and we're also listening on process.argv. So now it's time to see if it actually works. So I'm going to take this. I am going to paste it. And as you can see, or let's see, okay, just zooming into 500%, nothing big. So as you can see, I just, as mentioned, made a GET request where I'm passing in the ISO time in the browser. And so then that is being parsed here and being returned in the browser. So even though it's JSON instead of being HTML, because it is an HTTP request, we can really conveniently just see it in the browser. So it's nice. Then I'm also going to try the Unix time API endpoint. And yeah, we have our big string of seconds for Unix time. So that's pretty great. I guess it wasn't explicitly stated, but as you can see, we did make our URL API. So if you've ever heard of an API and wondered, what does that actually mean? You just built one. You just have a certain endpoint in your web server where people can send a request and get some sort of value like this. Maybe some APIs will be more complicated. Maybe some will require authentication. So for example, if you're trying to set up a Twitter API, then you will have to just fill out a bunch of forms, and then they give you an access token. And then just as you pass in something like ISO equals the date that you want formatted, you can also pass in your authentication token. And then if you have an authentication token that the API considers as valid, then you can get your data. Otherwise, it may return something like permission denied. So that is our, I was hoping there would be an option here that would just start from the current slide, but I don't see one. So unless any of these actually help, then. Okay, from current slide. There we go. I did not want to have to flip through all of the other stuff that we did. So, we have our TCP server, we have our JSON, we have our not explicitly API, but also we did just totally build an API. So now we can make that web page and actually show off our HTML5 supercomputers. So how do we go from serving JSON to HTML? The answer is actually pretty simple. Instead of returning JSON in string format, we're just returning HTML. So as mentioned, if you did make a GET request, you could view it in your web browser. So again, all we have to do is replace the JSON with HTML. So here is our basic server that, regardless of any request that's sent in, regardless of the type, we just have our HTML document. As you can see here, we have a form. So on the form tag, you can specify action, which routes it to a different URL to your server internally, and you can specify a method, either get or post. And after that, you can specify different input that you want. So for me, I just have text input. I have the name of it so that I can identify it later, and then I just have a submit form button. So shown is a screenshot of what it will look like in your browser when you run the server. It is very simple. As you can see, it's literally just a text box and a button. So now we can handle that form. So shown here is what we can do. So you can check the request method. You can check if it's either get or post. So here we have our if statement for if the request method is equal to post, and then we're going to do something to handle it. Otherwise, if it's just a get request, we're just going to return our nice blank form, which has been squished down for the sake of making the size readable. So this is basically how we are handling our post request. So we have our, basically the data is being given to us in chunks, and then we are adding each chunk to our body of post request data. So after we do that, we are parsing the URL. This is sort of a questionable way of doing it. I don't really think this is necessarily going to be best practice at all, but basically I just passed in the post data to the URL parsing function to parse it easily as if it were a get request, I guess. So then what we're doing, we're parsing it, and then we are doing, we are returning the data, just like a paragraph tag of I received a post request with this text input, and then we are giving the, so as you can see, we're doing URL parts.query.test_text. So because we have our input uniquely identified as the test text field, we can access that really nicely and see what was passed in. So as mentioned, definitely not best practice for parsing a post request, but it works for now. So here is our end result. We can make a post request using curl, but also you can just use your web browser, and I will do that in a moment. So this is just like what it looks like if you go to like localhost 8000, you type in hello, you click submit form, and this is what you'll see on your web browser. Or as mentioned, if you use something like curl or other software that lets you make a request, you can just specify the post format and the data that you want to upload, and then successfully make a request and then get the output on the command line of like, I received a post request with this text input. So quickly before we just do this like final thoughts slide, I guess I'll just run the server to show what that's doing. So again, we need to get rid of our other server, and then we're going to do HTTP post server. So really quick, I guess I'm just going to show that. So we have our server here. As mentioned, if the request method is post, we are just basically taking chunk by chunk of the request. We are converting it to a string and appending it to our content. So then after that, we are just ending with parsing our stuff and then returning to the user. Otherwise, we're just giving them the HTML. So we go here. As you can see, we have our text box and we have submit form. So we can type in something here. We click submit form and we receive a post request with this text input. So everything works. So final thoughts, this is the end of today's presentation, and luckily the timing worked out really well. So hopefully it was interesting. interesting. I know it wasn't like going through a web interface and breaking stuff, but hopefully it was interesting. If you are interested, know that like the final CS241 MP is that you do have to build a TCP client and server using C. You would, in theory, be able to test your code with the JavaScript client if you wanted, because it's both TCP as long as you use the right port number, then you would be able to test it. Of course, the MP is a bit more complicated because it does do more stuff to handle, for example, multiple clients at once. But the basic idea is the same. So if you liked it, then see how you like the MP in CS241. And if you enjoy it, then you can take CS/ECE 438, which is Intro to Computer Networks. And the first MP for 438 is also building a client and server, very similarly to 241. So as mentioned, this is a very basic server. Even for things like 241, or if you're, I don't know, trying to found a startup or something, I think your web server may be a little bit more complicated to handle everything, such as a lot of clients, maybe a slow connection, various network errors that can happen. So that's all that we have today in terms of the tech workshop. Does anybody have any questions? If no one has any questions, that's totally fine. As mentioned, in terms of coursework that's relevant, CS241 and CS438 are great. I'm not really familiar with the EC curriculum, but 391 is supposed to be very similar to 241, so I assume that maybe they also have a networking component here. And yeah, as mentioned before, if you are building like a web app, you are definitely going to start from a higher level than what we covered, probably starting with a big web framework. But hopefully this was still interesting to show how does that actually work below this high level thing, and just show that like you don't need a really heavy web framework to build a web server. If you really do just want to show basic HTML, you just need a few lines of code. So
Yeah, so thank you for everyone that attended today's tech workshop. And also, of course, thank you to Daniela for putting all this together and for